We propose Self-Supervised Multimodal NeRF for autonomous driving, also known as NVSF. Our framework uses data from both LiDAR and camera sensors of an autonomous vehicle to train its network. Once network is trained, we can synthesize novel views for both the sensors, LiDAR and camera, which can be used for various perception model of an autonomous vehicle. Most of the NeRF-based framework are either targeted for LiDAR domain or camera domain. There are few frameworks which support multimodal NeRF for real-world driving scenes which contain static and dynamic objects. But these frameworks require external supervision for learning dynamic scene content. Our framework learned neural scene representation for both LiDAR and camera fields without any external supervision. We experimented with different approaches in order to derive the best strategy to deal with camera and LiDAR modalities. First, we checked the reconstruction performance using common encoding for both LiDAR and camera. Then we experimented with implicit fusion of LiDAR and camera modalities. Lastly, we checked the performance using the separate encoding for both LiDAR and camera. Separate encoding performed best among all because LiDAR and camera modalities converges at different rate. Using separate encoding also prevent uncoordinated convergence issue. We have used heuristic-based pixel sampling by using the reconstruction loss of pixels from LiDAR panel and camera images during training. Pixels with high reconstruction loss are sampled more often than pixels with low reconstruction loss. Consequently, network was able to learn pixels with rich information. In order to improve the effectiveness of gradient loss, which was used for the feature alignment of point cloud, we proposed to use double gradient for the calculation of clipping mass of gradient loss. Compared to left and right figures, later has more black points, which indicate that the gradient loss was applied on more points compared to single gradient based clipping mass. Finally, we are showing the qualitative comparison of our framework with LiDAR NeRF and LiDAR 4D. Our framework has outperformed both LiDAR NeRF and LiDAR 4D in synthesis of LiDAR point cloud. In addition to LiDAR point cloud, our framework can also synthesize camera images. Hence, it provides single solution for realistic and accurate novel view synthesis of LiDAR and camera sensors of an autonomous vehicle. Here are few examples of view synthesis using our framework.